Hey, Mr. Maz here.
And Jenna.
We're going to continue our talk on linear relationships, and you'll see the fire in the background here, a little precursor of what we're going to be talking about. So the weather has been beautiful out lately, and we've had a lot of fires here, and we love roasting marshmallows. But this topic for linear relationships are the different types of ways that you can represent a linear relationship in an equation. And everybody loves a good campfire treat called a s'more, and there's more than one way to make a s'more.
This is a good old-fashioned way to roast your marshmallow. This is the way you do it by the fire, and you get to spend time with friends and family. You get to enjoy the warmth while sitting at the fire, and your marshmallow is always gold, brown, and toasty and ready to go. Teamwork makes the dream work. This s'more is so delicious. I'm gonna dream about it tonight. But who likes that smoky smell and burning eyes? Not me. But this is the fast and easy way to do it. Plus, you can make it all year round, snow, rain, or shine. This was so delicious. I give it a 10 out of 10. I mean, it is a s'more, so who wouldn't?
Now, while the microwave does eliminate the smoke and you can do it all year round, roasting a marshmallow over the stove still allows you to get golden brown and toasty, and you never have to worry about burning it in the flames. No need to build the fire, and look how golden brown that marshmallow is. And look at that warm, delicious, melted, chewy, ooey gooey s'more. Delicious. Now, the whole point about talking about the different ways to make s'mores is to talk about the different ways that you can have the equation of a line. Just like making the s'mores, each has its advantages and disadvantages, and none are really right or wrong. Some are more useful in certain situations than others, so it's nice to know all three and become familiar with all three so you can decide what is best. So the first one, and probably the most common form, is the slope-intercept form. There is also the standard form, and then there is point-slope form. The slope-intercept form we should be very familiar with at this point. Y equals mx plus b. M equals the slope or the rate of change, and b is the y-intercept, where the line crosses the y-axis. Like I said, it's probably the most common form used, and what's nice about it is the equation can easily be found from a graph, and also once you have the equation, it can be graphed very easily as well. A quick example of some things that you might see. If you are given or you find that the slope is 3 and that the y-intercept is -7, you substitute the 3 and the -7 in for the m and the b, and you get y equals 3x minus 7. Notice you don't have to put plus -7 here. Plus and negative is the same thing as subtraction, so you can just use -7 here. Standard form, it looks like ax plus by equals c, where a, b, and c are constants. This form, as well as all of the other threes, when you have the x and y as variables, those represents points on the line. Remember that a line is made up of an infinite number of points, so any combination of x and y that make any of these equations true represents a point that is on that line. So those are always the variables. That's why we keep them x and y. One of the great benefits of the standard form for a linear equation is finding the x and y intercepts. If we look at this example down here for a standard form, burgers are $4 each and cheeseburgers are $5 each, and the total amount spent was $40, where x is the number of burgers and y is the number of cheeseburgers. 4x plus 5y equals 40. So I want to use that example here to show us the benefits of using the standard form. So let me go ahead and pull up some writing utensils here. So if I have 4x plus 5y equals 40, and I want to find the x and y intercepts. Remember, the x-intercept is when y equals 0. So if I'm trying to find the x-intercept, I'm simply going to put 0 in for y. And standard form is so great for this because essentially this y component cancels itself out. So we just have 4x equals 40, which is quite simply 10. So the x-intercept would equal 10 in this point. What that basically means is if you only bought burgers and no cheeseburgers at all, you could get 10 burgers total. If we want to find the y-intercept, we do a simple approach. So for the y-intercept, we would simply put 0 in for x instead, because the y-intercept is when x equals 0. That's when you are on the y-axis. Every value of x is 0 when you're on the y-axis. So once again, the x component cancels itself out. I'm not exactly sure why I put a equal sign there. That should have been a plus sign for the equation. So we ended up with 5y equals 40. And if we divide by 5, we end up with y equals 8. So if you didn't buy any burgers and you only bought cheeseburgers, you could buy 8 total cheeseburgers. All right, so graphically, what that looks like, we have our coordinate plane here. The y-intercept, like we talked about, was 8. So we would come up here to where 8 is, and that could be a point for our y-intercept. And the x-intercept was 10, and that would be our x-intercept out there. So if we were to draw a line for this situation, it would go through those 2 points. So using the standard form, if you can find the x and y intercepts, it's pretty easy to graph as well. We talked about, once again, the 2 main components of a linear function is the initial point, so in this case it would be 8, and what the slope is. If you can find the x and y intercepts, it's actually pretty simple to find the slope as well, because of the zeros, it makes it easy to find the rise here. So the rise here, since it's going down, is -8, and then the run here is 10, so we're looking at -8 over 10, which will simplify to -4/5 in this situation. So if you look at kind of finding the slope, if you take the opposite of the y-intercept over the x-intercept, you will give the slope. Now, please don't look at this 4 and 5 as a shortcut. This is just a mere coincidence here. So while that's a coincidence, it is important to note that with this information, we can very easily change standard form into slope-intercept form. The only thing we need is the slope, which is -4/5, and the y-intercept, which we know is 8. So we could have y equals -4/5 x plus 8 if we needed to change standard form into slope-intercept form. Now, the last one to talk about is the point-slope form. All right, so once again, point-slope form has its advantages. Namely, if you just look at the name of it, if you were given a point and the slope, so with the slope-intercept form, we're given the slope and the y-intercept. Y-intercept is a specific point when x equals 0, but say you don't get an intercept, say you just get some random point. If we look down at example, what if we get 5, -6 that's on the line, and the fact that the slope is 4? So if that's a situation, we can use the point-slope form. And this is kind of like a formula to use. M still is the slope. X and Y, like we talked about before, are any point that is on that line that satisfies the equation. But x1, y1 is that specific point. So if we look at the example, a line has a slope of 4 and goes to the point 5, -6. We substitute 5 in for x sub 1, and we substitute -6 in for the y sub 1. Now what I need to point out here is this changes to y plus 6. In the formula, you notice it's y minus y1 and x minus x1. You're actually subtracting the values of the coordinates there. But we all know if you subtract a negative, so it's really y minus -6, that turns into addition. But because 5 is positive for the x, we leave that as subtraction. Now, the nice thing about point slope form is it can very easily be changed to y equals mx plus b. If we just look at the equation that we have here, y plus 6 equals 4x minus 5, the first step in changing this to slope-intercept form is using the distributive property. So we're going to leave the y plus 6, and we're going to distribute that 4 to 4x minus 20. And then to get y by itself, which is kind of the goal of slope-intercept form, we need to subtract the 6. We cannot subtract it from 4x because they're unlike terms, so we're going to subtract it from that negative 20. And we end up with y equals 4x minus 26. So that would be how we could change point slope form into slope-intercept form. We also saw how we could change standard form into slope-intercept form. So it's important to recognize that while each of these has its own uses, they have disadvantages and advantages, you can always change in between the different forms. I want to talk real quick about the use of point slope form. A main use of it is if you're trying to find the equation of a line and all you're given is 2 points. Between 2 points, it's very simple to find the slope. And once you find the slope, you can just use any one of those points and substitute it into the point slope form formula and come up with the equation. Your assignment is on ALEX. It's called Different Forms of Linear Equations. It's abbreviated to only 7 questions because there is no school Friday because of the Easter holiday coming up. I'll also try to make it available earlier than usual. I'll try to get it out by Wednesday morning at the latest. And from my family to yours, I hope everybody has a safe, healthy, and a happy Easter.